Hello everyone, and welcome back to another video. So, here we have the GTX 780 I Can't Be Bothered edition, a GPU that I put away quite a while ago to maybe do some more things with at some point. And I have not done something with it at this point. So, this is now a demonstrator card for something that I've been thinking about, but really I did this because ASIC, who's another YouTuber, asked me about this because, well, I have this piece of hardware that's uniquely qualified to test the theory of his, and I did, and it did work out, and that's what the video is about. So, essentially, when I built this card, like this is the 780 I Can't Be Bothered edition, that pretty much tells you everything you need to know about this. This is a card that I made working, but didn't really care how well it worked. It did actually it did work surprisingly well. The actual voltage regulation on this thing is awful, but it clocks pretty well for this. But yeah, so this is essentially a disposable card. I don't need to have this. I have a different 780 that I also have e-power that is much better than this one. And this e-power board is also not really anything special. The main problem with this e-power board is actually, kind of why this entire project started in the first place. So, really what all of this started with is that ASIC had the idea to make a custom PCB for an e-power board. But instead of just designing a e-power board from scratch, which would be, kind of difficult, he decided to just take the VRM components from, in his case, a GTX 560 Ti DirectCU2, which he has turned into e-powers before, and take all of those components, put it on his custom designed PCB, and then have an e-power that is essentially just that 560 Ti VRM, but on a PCB with much, much better hookup points. Which you can see right here, that this is a 580 DirectCU2 VRM, it has the exact same problem. The VRM on it is very nice, very powerful, it even has dual outputs, and the controller is very easy to get working. I just took 5 volts, 3.3 volts from the card itself. I didn't need to add anything to this, just soldered 2 wires and it fired up. But the problem is this. This is all the hookup you get, and you can see that even with how horrible the soldering on this is, there's not really anything I could have, done better in terms of having more connections. And that's really the main problem. So you have something that you can easily turn into an e-power, you have a VRM on it that's strong enough to actually be usable as an e-power, but then you have a PCB that only gives you this much to actually connect to something, and that's why he wants to design, or attempt designing, that custom PCB. Now to do that, he of course had to reverse engineer the entire VRM on that 560 Ti, which happens to be quite similar to this 580 VRM, and while he was doing that, he came upon the idea that also I had the idea a while ago but never implemented it, is to implement forward voltage sense. Now, basically what this does is it lets the e-power take a voltage measurement at the GPU core instead of at the output, which, has a lot of advantages because it gets rid of all the... Well, it doesn't really get rid of it, but it allows the VRM to compensate for the resistance and inductance that your connections and your power plane have. And also it is gonna help you not drop a whole bunch of voltage for no good reason. This does have an LLC, but when you e-power something, you usually get a very large voltage drop from your e-power to the actual thing you're powering, just because of there's all of these connections and the power plane that it has to go through, and the e-power can't see what voltage you get here, it only sees what voltage you get here before all of the drop-off. So, typically when you e-power something, you get a lot of voltage drop, which also changes depending on load. At idle, when it's not pulling much, well then, you get high voltage, but as soon as you put a load on it, your voltage can drop a lot, and this is a perfect example again, because this is made so horribly. This thing was I had to set 1.4 volts on it for it to like run stock clocks, because it would idle at 1.4 volts, yeah, but if you put a load on it, it would go down to like 1.1 volts. So this had a horrible case of way too much voltage drop that wasn't intended. This was not LLC. And the forward voltage sense mod would get rid of that. It would allow the VRM to actually regulate the voltage based on measurements from the actual GPU core, not just the output. So it can compensate for everything that happens in between here. And I first had that idea when I managed to get the memory VRM on my GTX 480 power boards working by just, but the thing I did to make that work was just wire the output side of the feedback pin to the actual output, because as it turns out, when you cut the card, it gets disconnected, and that's what makes the VRM work. And I was just like, well, what if I just connect that to like the furthest memory chip instead of just the output? That would, let the feedback pin see the voltage that's like far away from the VRM output and, include all the losses from the power plane. And I had that idea, planned to implement it, but never really did it. And then ASIC started his project and had the same idea again. And because the VRM on this power board is so similar to the 560 Ti VRM that he's trying to re-engineer, he did find the vCore and ground reference points on this controller. So we have this wire right here. That's the feedback pin, so for the volt modding. And then these two are new. This is what actually makes the forward voltage sense work. So the green one is vCore and the white one is ground. And if you flip the card over, you can see how that goes to a capacitor behind the core. So it is taking the voltage measured at this capacitor behind the GPU core, and through these wires, it's feeding it to the controller. Now I first had to cut the original traces. You can kind of see it here. I went in with a box cutter knife and disconnected those two traces, because that is the normal sense traces that, sends the voltage right here, typically. And, we don't want that. We want just purely measure the voltage that's here, so I disconnected those two traces and then put those wires there. And this actually works beautifully. Like, I can set 1.2 volts on the e-power, and under load it will have something like 1.18 behind the core, which is intended, because that drop of 20 millivolts, that's the actual LOC on the VRM. So that is actually great. It in theory can also help you with your actual voltage regulation, because the VRM now can compensate for the resistance and inductance of your power plane. Doesn't have to mean it's doing it particularly well, especially like an older VRM like this might not be the best at it. But in theory, it can improve your voltage regulation because of that. In practice, I do have my oscilloscope hook up like back here. This VRM is still horrible. Not because the mod is a bad idea, but because of, this. So this still gets like 300 millivolts peak to peak. And the minimums are, if you set 1.3 volts, your minimums are in the 1.05 volts range. So, yeah, not that great. So, yeah, but the actual point of this project was to demonstrate forward voltage sense working, and it did work very well. So, this is a thing that this card has now demonstrated is possible to do, and I think it does actually have enough of a benefit to consider doing this always when you build an e-power, or more like connect an e-power to something, because it just like the theoretical VRM regulation, like voltage regulation improvement alone, might be worth it to some people. I also just like it because, you put a load on the card and your voltage doesn't drop like 150 millivolts for no good reason anymore, which makes it significantly easier to use. This is, I guess this is dailyable now? Like it won't idle at 1.4 volts anymore, because over time that might just actually degrade the GPU. So yeah, but really, yeah, like this mod, very, very nice, how it does actually work out. And it's not that hard to pull off as well. Like, it is different how you implement it, really, like, based on which controller your VRM has, but normally you have a feedback pin, and then your controller will have a sense pin for like vCore, like the output, and then a ground sense pin, which is like sense plus, sense minus. Some controllers don't have a feedback pin, like the CLJ8266. For example, it doesn't have a feedback pin. It uses its sense plus pin as the feedback pin, kinda. So that's a bit different, but usually you have a dedicated feedback pin. And really, how this is implemented is just the feedback pin is connected to a voltage divider between the output and ground. And both ends of that voltage divider are usually also connected to the two sense pins, the sense plus and sense minus pins. And all you really need to do is just find a resistor, or like any SMD, that's connected to both of those pins, and then just connect either to that or just find a trace and, like, you know, cut the trace first, of course, and or just like solder onto what remains of that trace, and there you have your sense lines. Yeah, like looking at the typical application diagram of your controller, if you have it, could be useful for this. Like, I soldered this purely on the basis of ASIC saying, yeah, those two traces, try to cut those. So I don't actually have a datasheet for this controller because it's like a rebranded Asus SHE something. I think it's like a UP6208, but I'm not sure what it actually is. So I didn't really, you know, super verify that everything works exactly like I just described, but in theory it is. And he and me, we both have acquired a GTX 480 circuit diagram PDF. We don't have a board view, which makes things slightly more interesting, but we have a PDF that shows like all the connections on the PCB, and we identified what we think is the sense lines on the GTX 480. So, you know, I have this 480 sitting on my desk for a while now. This is actually one of the cards I modded. I have removed most of the mods from it. Like, this is still on, those are still on, this is still on. But this card is dead. Like, this has dead memory on it. And so basically it's getting turned into an E-Power because I have two more GTX 480s that don't have dead memory on it. So, you know, this is getting cut, this is getting turned into an E-Power. I'm gonna also run the memory VRM on this since I now know how that works. And, well, this is gonna be the next demonstrator for this, since, you know, like I wrote down right here, it has a CHA8266. So this is a controller without a dedicated feedback pin. This just has the sense plus and sense minus. Yeah. So, like, I don't exactly know which ones it was, but ASIC already said that he found two resistors that he thinks are the ones. Well, yeah, he pretty much confirmed they are the correct ones based on just their resistance, because the PDF says they have 100 ohms of resistance between, you know, output or ground and those pins, and they are exactly that. I don't know which ones they are, but somewhere in this area there's these two 100 ohms resistors. We disconnect those from whatever trace they're connected to, and then just, you know, once this is cut, connected to whatever we're powering with it. So this is probably also gonna turn into a demonstrator, and then this is like actually GTX 480s are becoming like a very, very nice option for like E-Powers, because now we know how to run both VRMs on it. We know how forwards voltage sense works. As you can see, this right here, it has I2C. And what we also found out after looking at the PDF is this right here, this unoccupied spot right here. Yeah, that's the enable pin. That's the enable pin for this controller. Like, all the goddamn time we were soldering like idiots to like this little pad right here, which can very easily be ripped, and did get ripped by many times, like by me. You can just solder onto that, which is actually like meant to have things soldered into it, like this. Yeah, like the PDF just says, oh yeah, this is the enable pin for the 8266, by the way. So yeah, like 480 power boards are starting to look really, really attractive for like the only drawback they have is that they only have a 6-phase V-core. But like anything that's like 200, 250 watts max is gonna run just fine on this. For more power than that, well, I mean, this thing has the PCB problem. Yeah, for higher power things, maybe just try to find an ePower 5. But yeah, these VRMs, these PCBs, like GTX 580 PCBs should also work for this, like as long as they are the reference, since it's basically the same layout. So very, very, yeah, interesting things ahead. I just need to start doing them. But yeah, really, it's a successful demonstrator now, and that also means like this card actually has a purpose now. Like I always said, it's just like, so like the only reason why I'm e-powering this is because of that. The card came like this because the upper 2 phases in the V-core VRM just exploded, and you can't run a reference GTX 780 on 4 of its V-core VRM phases. That's just not gonna work. Like the other 2 phases are gonna look like this within like 5 minutes if you try to run a load on that. So I was just like, so the only way to make this card work is an e-power, but I already have an e-powered 780. So this is not really worth putting an e-power on, but then still, it's a perfectly functional GTX 780 outside of those 2 dead phases. So I was just like, well, let's put an e-power on it, but like not a good one, just one that I wasn't gonna use anyways, which is this one, because the hookup points are horrible on this. So yeah, and it was a very horrible e-powered 780, but now it actually has, you know, this on it. So it is now a technology demonstrator, which sounds way cooler than a really shitty 780 that I made. And yeah, I do actually plan to overclock this a bit more, because I'm just interested in, like, I never really full-on overclock this one. I was planning to do this anyway, but now with this one it's like significantly easier to use, so I'm actually gonna mess with this some more. Like, I don't know what I'm gonna do. Maybe am I gonna solder more things to the back of the core? This area already looks horrible. Like, I also didn't really, like, you know, I did not care about things looking properly on this. So like, this has flux over it, burnt areas, like this cap mod is also horrible. I don't know, maybe I'll add something more to this card, but like, well, there's gonna be some things done with this card now. It's just interesting that this works now, and I will try to implement this on more cards, and then find like a somewhat consistent way of finding the traces and connecting things. So there's I guess I could make like a somewhat guide about it. I mean, I already kind of gave a guide in this video, but just, yeah, it's probably not a very good guide. Anyway, so I think that's it for this close to 20-minute video about 2 wires I soldered to my horrible GTX 780. And until next time, goodbye.